Hello students, welcome back. In today's class, we will learn a new chapter, that is geometry chapter, congruency. Now what do you mean by congruency? Now you can take few examples from our daily life. Now in our daily life, we come across many objects of different shapes and sizes, correct? Some of these will be of same shape and different sizes, and some may be of same shape and same size. For example, a figure and its carbon copy are surely of same shape and same size. Similarly, two photocopies, that is the Xerox copies of the same document made to the same size, are figures of the same shape and same size. So, what do you mean by congruency? That is, two figures having the same shape and same size are called congruent figures. And two figures in a plane are congruent if we can superpose one figure over the other so that they cover each other exactly. Now I can show you one example. You have two coins, okay? If you observe the coin, they have the same denomination, that is 5 rupees coin. If you place one coin over the other one, from the top it looks as if it is a single coin. This is called superposing, or you can say superimposing one on the other. Now suppose if you take your maths textbook, if you place one maths textbook over the other, if I am talking about the 9th standard maths textbook, now we can say that they are superimposing one another. Now coming to the plane figures, now line segments. Suppose you have two line segments each measuring 5 centimeter. You can say those line segments are congruent. Then angles. Two angles are congruent if they have the same measure. Suppose 60 degree angle. So two angles having the same measurement of 60 degree are congruent. Square. Now when we think about square, a square will be congruent to the other square if they have the same side. Now what about the congruency in triangles? Now this chapter deals with the congruency in triangles. Now if you know about triangles, there are 6 elements, that is 3 sides and 3 angles. So here the 3 sides and 3 angles plays a major role in defining congruency. Two triangles are congruent if all the sides and all the angles of one triangle are equal to the corresponding sides and angles of the other. Now if you observe the first triangle ABC, here ABC are the angles and AB, BC and AC are the sides. And you have another triangle DEF, where DE and F are the angles and DE, EF and DF are the sides. And it is already marked that angle B is equal to angle D and angle C is equal to angle F, angle A is equal to angle E. See, this marking tells that A is equal to E, B is equal to D and C is equal to F. Similarly, the sides BC is equal to DF, AB is equal to DE and AC is equal to EF. So here 3 angles and 3 sides are equal. Therefore triangle ABC will be congruent to triangle DEF. Now if you have observed, this is that is equal to and similar. So this symbol is the symbol for congruency. This is the congruency symbol. Equal and similar. Now we will learn more about congruency in triangles. Now in congruent triangles, the sides and angles that coincide by superposition are called corresponding sides and corresponding angles. Now if I compare with these two figures, you see when you place triangle DEF on triangle ABC, EF will fall on AC, DF will fall on BC, and DE will fall on AB, because these are the equal sides. We call those sides as corresponding sides. Similarly, angle D will fall on angle B, angle E will fall on angle A, angle F will fall on angle C when it is superimposed. So these are called as corresponding angles. The corresponding sides lie opposite to equal angles and corresponding angles lie opposite to the equal side. Now you should know one more rule for congruency, that is corresponding parts of congruent triangles are also congruent, that is CPCTC. If 3 elements of one triangle is equal to the 3 elements of the other triangle, automatically the remaining 3 elements become equal to each other. That is called corresponding parts of congruent triangles are also congruent. Now we will learn the rules for congruency, that is the conditions for congruency of triangles. Now here you have two triangles, triangle ABC and triangle PQR, where here it is marked BC is equal to PQ, AC is equal to QR, and AB is equal to PR. Now what does this rule say? If 3 sides of one triangle are equal to the 3 sides of the other triangle, the triangles are congruent. That means in this case you have two triangles. The triangles are ABC and PQR. So the elements which are equal, it is marked it as BC is equal to PQ and AC is equal to QR and AB is equal to PR. Since 3 elements of triangle ABC is equal to 3 elements of triangle PQR, triangle ABC is congruent to triangle PQR. By which rule? It is by SS rule. SSS means side, side, side. 3 sides of one triangle is equal to 3 sides of the other triangle. So automatically they become congruent to each other. Now the second condition says if 2 sides and included angle of one triangle are equal to the 2 sides and included angle of other triangle, the triangles are congruent. So here 2 sides and one angle, that is side, angle, side. Now included angle means the angle should lie between the 2 sides. The equal angle should lie between the 2 equal sides. Now you can observe this example. You have one triangle ABC and triangle DEF. In triangle ABC and DEF, the elements which are equal, that is angle B is equal to angle D. It is given, and BC is equal to DE, BC is equal to DE, and AB is equal to DF. Therefore, triangle ABC is congruent to triangle DEF. Now if you observe, the angle which are equal, they lie between the equal side. This angle is lying between the two equal side. Similarly here also the equal angle lies between the two equal side. So these two triangles are congruent by SAS rule, side angle side. Now the third condition, if two angles and included side of one triangle are equal to two angles and included side of the other triangle, then the triangles are congruent. We call this as ASA, that is angle side angle. Now if you see, this equal side lies between the two equal angles. Now here you have triangle ABC and triangle PQR. Now in triangles ABC and PQR, angle A is equal to angle Q, angle B is equal to angle R, two angles, and the sides, if you see, this is called as included side because it lies between the equal angles. AB will be equal to QR. So triangle ABC will be congruent to triangle PQR by ASA rule. Now when the two angles of a triangle is equal, obviously the third angle will also be equal because sum of the angles of a triangle will be equal to 180 degree. So here you can write angle C will be equal to angle P by CPCTC. Since we have already proved that triangle ABC is congruent to triangle PQR, angle C will be equal to angle P. I told you, when three elements of one triangle is equal to the three elements of the other triangle, automatically the remaining three sides will be equal because of corresponding parts of the congruent triangles are congruent. You can either use CPCTC or you can write CPCTE. Corresponding parts of the congruent triangles are equal. Now moving on to the next condition, that is the fourth condition. If two angles and one side of one triangle are equal to the two angles and the corresponding side of the other triangle, the triangles are congruent. Here the side is not lying between the two equal angles, but the side is opposite to the equal angles. Now here you have an example. Two triangles, one is triangle ABC and the other one is triangle DEF. Here angle B is equal to angle E, angle A is equal to angle D, and BC is equal to EF. If you observe this side BC and EF, they are opposite to the equal angles. Here BC is opposite to angle A and EF is opposite to angle D, and angle A and angle D are equal. So triangle ABC is congruent to triangle DEF by AAS rule. And the last condition, this is exclusively for right angle triangles. Now that means this condition is only used for right angle triangles. Two right angle triangles are congruent if the hypotenuse and one side of one triangle are equal to the hypotenuse and the corresponding side of the other triangle. We call it as RHS rule. This is right angle triangle, hypotenuse and side. So whenever you have to apply this rule, you make sure the two triangles which you are comparing should be a right angle triangle. Now you have two right angle triangle. One is triangle ABC, which is right angled at B. The other one is triangle DEF, which is right angled at E. Now the most important thing is hypotenuse should be equal. Now AC is equal to DF. Hypotenuse are always opposite to 90-degree angle, and AB is equal to DE, and angle B is equal to angle E is equal to 90 degree. Therefore, triangle ABC is congruent to triangle DEF by RHS rule. So you make sure the hypotenuse is equal in both the triangles, otherwise you cannot apply this rule of congruency. Suppose you have two right angle triangles and these two sides are equal. You cannot apply this rule, because if you have to apply the RHS rule, make sure that the hypotenuse are equal. So these are the 5 conditions for congruency of triangles. The first one is SSS, followed by SAS, ASA, AAS and RHS rule. RHS is exclusively for right angle triangles. Now before we start with the exercise sum and the application of these rules, you should know few more terms. The first one is median. The median of a triangle corresponding to any side is the line joining the midpoint of that side with the opposite vertex. If you see, here you have a triangle ABC and a line is drawn from the vertex on BC. So if AD is the median, it will divide BC into 2 equal parts. So if AD is serving as a median, it will give you BD is equal to DC. In a triangle, you will have 3 medians. So if I say BE is a median, so it will divide AC into 2 equal parts. Similarly, you will have one more median. This is CF. So if CF is the median, it will divide AB into 2 equal parts. So you get AF is equal to BF. Now for a triangle there can be 3 medians and the point of intersection. Now here this is the point of intersection of these 3 medians, and the point of intersection of the median is called as centroid. You should know all these names. So centroid is the point of intersection of the medians of a triangle. The next one is altitude. An altitude of a triangle corresponding to any side is the length of the perpendicular drawn from the opposite vertex to that side. The point of intersection of the altitudes of a triangle is called as orthocenter. Now that means an altitude is actually is a perpendicular, so it makes an angle of 90 degree on the opposite side. So you will have 3 altitudes for a triangle. So if this AD is one of the altitude, BE will be the second one, and CF will be the third one. So altitude means it only makes an angle of 90 degree. It won't divide the opposite side into 2 equal parts. Division of side into 2 equal parts is done by median, whereas altitude just make an angle of 90 degree. And the point of intersection, now suppose if G is the point of intersection of altitude, we call this point as orthocenter. And the point of intersection of perpendicular bisector, you know, it is called as circumcenter. And the point of intersection of angle bisectors, we call it as in center. So these are the few terms which you should know: median, altitude, perpendicular bisector and angle bisector. Perpendicular bisector bisects the side as well as it makes an angle of 90 degree. Angle bisector, it will only bisect the angle. Now in the next class we will continue with the same chapter with the exercise sums. Thank you, students.